We're going to do a video for you real quick. This one will be a short one. I don't have a whole lot of time this morning, but I did want to get on here because I was seeing some crazy stuff on some of the models. And then we had a 6.3 earthquake in Russia, and I think space weather might have had something to do with it. Okay, but what you're looking at here, guys, this is like a really good representation of how space weather affects us directly. Okay, and it gives us a very good visual of that. So what you're looking at, guys, I'm going to go ahead and start this, okay? It's a time lapse. So what you're seeing there is, what this map is telling you is the effects of, basically the effects of space weather on unnatural sources, such as power lines, transformers, and stuff. So it's telling you that basically it's giving you like a percentage of energy hitting that unnatural source. Okay, power lines, like I said, mainly. It's called the geoelectric model, is what this one is, and it's fairly new. And we don't typically see it doing this. Okay, usually it stays pretty dark blue the whole time. Now, Troy, the guy that caught it the one time, he started his own channel and stuff. Troy, I think his last name is Manning. As you're seeing this, he caught it and was actually purple and red and stuff. Right around the California wildfires, right around that area where they were shutting power off. So it made us wonder what the heck was going on with that. But anyway, I was looking at this, and that started doing that. So I've been looking at the magnetopause models too. Okay, so we had an earthquake in Russia, a 6.3, and so I started looking around, right? And I do think space weather had something to do with it, and let me show you. Okay, guys, this is the ACE model. Now we're looking at this, right? Now the yellow is the speed of the solar wind. Now, if you look at that at first glance, it looks like it's low, right? Well, this is why I tell everybody we need to, and I made a mistake like this on myself. That's why I say it. But we got to look at the range. Okay, usually that's reading like 300 or 200, right around to about 500. Okay, look at the range here. We're going from 2 to 1200. So when they do that, what they're telling you is that it's seen a reading close to 1200. Because there's no reason to have it go up that high, unless that's the case. So I start looking, and like I've said before, why do you see a solid line here? Because there are bunches of dots lined up next to each other. So when we get variable conditions, like fluctuating from high to low in very short periods of time, you get what I call popcorn, which is what the density was doing up here. Okay? So I'm going to point that out. So we had like 12, it was like, there was a reading of like 1200 or something like that, kilometers per second. That's very fast. All right. Normal kilometers per second is between probably 250 or 300 to like 500. That's on the high end of it. Anything above that we would consider fast. All right. Now, something else of note here, guys, is the density itself. Okay, you can see where it dropped out to nothing again. All right, and I could show you the Australian model, but it was doing some crazy stuff too. But why I got you here is because I want to show you the Enlil model. Now, this is the one that shows us 2 days behind us, okay, because we're right here in time, right? We're the green line. That's the conditions there at Earth. And then it tries to forecast 5 days out in advance, okay? So, judging by this, if you look at this, on the 9th, we're not supposed to be having anything but close to 500 kilometers per second. Okay? Density is low. They got that right. That's for sure. Okay, so, but they weren't predicting any of this, is what I'm trying to say. So this is coming from somewhere else. This is not a typical solar wind stream. Okay, now I guess we could have had a stealth solar storm or something like that could cause this, but let me show you something else. Okay, this is looking very similar to the other day when we were talking about the crack in the magnetic field, letting all that energy in. This is the electron flux. This is showing you electrons basically, without going into too much detail. When that thing goes down, that's actually spiking up, so you got to keep that in mind. That's a pretty long duration. Now, the other day when we seen this, it lasted like 12, 14 hours. I'm hoping this one doesn't do that. And again, that was even unexpected back then, a couple days ago. And like I said, I spoke about it. Now, this is these right here, whenever you see these straight lines that are only there for a second, most likely those are cosmic ray bursts. Okay, that's what a cosmic ray usually does. That's how these models pick it up. You'll see just one little straight line like that. But it looks like we had quite a few right there in a row. Now, like I said, right there, that's disturbed conditions, guys. So, but let me also, their Aurora model here is actually showing a little bit of truth there. Okay, because they're saying, it looks like they're saying that we're going to see some auroras. Not down where, you know, if you live in the States, you might see them up towards North Dakota, Montana and stuff. But it doesn't look like it's going to get down in the mid-latitudes, like running around. You might see some high up in the mountains in Colorado or something. But watch this as it comes around. And this is, again, this is a prediction model, okay, or a forecast model. And, that, you know, you can look at the timestamp. Now, see where that got red right there? They're saying that that's a very high chance that there's going to be auroras right there. It's like 90%. So that's what that's telling you. And also, if you look right here, look, we're at a 4 on the KP. You see that yellow right there? If that gets to a 5, that's a G1 level magnetic storm. Okay? If we get that high, I'll be surprised. But in a way, I wouldn't, because we've been seeing these things happen in the past week or so that were not expected or forecasted at all. And this is why I'm bringing it up. But let me show you this other model real quick. Okay, this is the Magneto-Pause model that I show you guys quite often. This is over at ISWA. This is a top-down view. The sun's off to the right. So keep that in mind for orientation reasons. Now, what I'm going to show you here, guys, is pretty intense, but I'm just going to run it through here real quick so you guys get a glance at it first anyway. So we'll go through here. Boom. Whenever it jumps like that, guys, it just went down for safe mode most of the time. We're missing like 20 minutes right about there. See how it jumped like that? It has to do that or it'll get damaged. Now, I'm going to talk about this here in a second, but I want you guys to see the whole thing real quick. Okay, see how we're contorting really bad out in the front and all that? This is really getting, it's a pretty decent hit, guys. Okay, but check it out in the back. Okay, we're going to start it right there. And I could take it back in time, and some of this is even there, even a little bit further. But we're seeing some energy, obviously, here on the back side. But what I find interesting, typically, like I said, the sun's over here. And when the sun's shooting solar wind at us, usually it's pretty symmetrical. Okay, we'll get higher pressure or higher dense material here doing one of these and down here at the same time. And it'll have like a small little section that kind of looks like that. But watch what happens here. See how that right there, what does that resemble? If you took that and flipped it around, it would look just like what's out in front of us. Our bow shock. Okay, so what I'm saying there is that the Earth, when it does this, it's trying to protect in all directions. Okay, the magnetic field is more like a donut. It's not just straight lines and parallel this and parallel that. It's three-dimensional. Stuff can crawl over the top and come into our poles, which is where most of the energy typically does come in, at our poles, magnetically. Okay, not geographically, magnetic. All right, there's a difference there. I've explained that quite a few times. I'm sure I'll do it again, but I don't have time to do it today, guys. I'm sorry. But as we go through here, watch how it just keeps on going out. See? All right, then it jumped time. Now, that is more of what we typically see when we're getting backside stuff. You see these? Okay. So I'm going to go forward here, and you're seeing it do it again. See? It's resembling the front. And then at the same time, guys, like I showed you before, we're open in the front there too. Not completely, okay? Whatever's making it past the bow shock is having an easier way in right there. That's all I'm saying. We're not like completely wide open to the sun right there. Our bow shock is still there, and so is a lot of our other protections. It's just making it easier for it to get there. Okay, so as we go through here, I've seen something interesting. I've seen this before. Number one, this energy is getting really close to us, period. Okay, it's well inside the satellite line. which is the dotted line. Okay, see how close that is in right there? And then I started picking this up. It's doing the same thing as it is in the front. It's kind of open right there in the middle. So, what I want you guys to look at here, now I'm just going to, hate to even call it this, but it looks like the Earth's getting ready to fart. All right, just watch this. Okay. Boom. It did it right there. Now I'm going to back it up and I'm going to go slow. First thing I want you guys to look at, guys, is out in front, actually. You see how it's all contorted and stuff? All right. Now, we could talk about directional and all that kind of thing too, but it is directional in my opinion right now. But watch out there where let's see here. Watch right in here, okay? Right there it went. Now watch. See where that, just keep your eye right here where that satellite icon is. Okay, what did that look like to you guys? I'm rocking it back and forth. Okay, there's the start of it. Now watch, here it goes. Boom, it blows out, right? You see that? Like an explosion almost. What that reminded me of was like a CME or a solar flare blowing off of the sun, which I'm not saying that's what happened here, guys. Don't think that. All I'm saying is it didn't look like that. So what do I think is happening? Well, I think what's going on is the Earth is acting like a capacitor. Okay? It's collecting this energy and it has to release it. And that's what's happening right there. It's releasing that energy. It doesn't have to do it in the form of plasma like the sun does, okay? But this definitely looks like something is releasing from the Earth, from the inside out, okay? That did not come from the outside. Because I'm going to go forward in time, watch. It shows up right there and then boom, it blows out the back. It doesn't go towards the front. So what I'm saying there, like I said, I think we've gotten enough energy there, and as that thing, as the Earth just built up so much, it had to release it. Okay. Now I've said this before. I was a print tech for supervisor and stuff at a printing facility for over 20 years, and the printing machines that we used capacitors. Basically, they're just they look like a battery that they just hold energy pretty much. Okay, I'm not going to go into detail. But you can control that in the machine when it releases that energy. Okay? They're inside transformers and stuff too. So, but I've also seen, being around that stuff, when those capacitors hold too much energy, they explode. They'll catch on fire. All of that. Okay? So that's why if the Earth is acting like a capacitor in this instance, it had to release that. Okay? So that's kind of what it looks like to me. Now, I do think that all this stuff that we got going on in the front here is most definitely probably had something to do with why that earthquake cracked off. Okay? Because you can see clearly, guys, that that's intense. All right? Like I said, there's no gloom and doom in this. I'm just trying to make you guys aware. I mean, nothing is anything like crazy, but that is something that I've never seen before. It looks like the Earth farted. I mean, that's just crazy. But yeah. Sorry to call it that, but I'm sorry if that offended anybody. But and at the same time, the Earth did that in the front. In the back. Look what it's doing in the front. Okay, it's kind of doing the same thing. See how that kind of even bent out? Look right here. See how it kind of bent back that way as it's starting its thing back here. So that's telling me. Well, I just now noticed that if it's blowing out the back there, it's probably blowing out the front also. Because it'll release it in all directions. Okay? It's electricity. It's going to find the path of least resistance. Okay, just like water does. Most things flow like that. So if it's not resisting right there, it'd be easy for it to go. Right? That's what it does. Okay, because like even electricity at its core is just a flow of electrons. And notice I use the word flow because that's what it does. It acts very much so like water. Now again, watch out and back there, guys. Boom. So yeah, I just wanted to show that to you real quick. I'm going to show you something else. One more thing. Yeah, guys, we had another CME yesterday, but it was not Earth directed, so I didn't come over to you guys real quick or anything. But I do want to show it to you, okay? I'm going to show you this too while we're at it. Bear with me here for a second, guys. Sorry. Okay. So I got you here. This is Lasco. This is, typically we look at this over on Seeds, but Seeds is not updating right now. Okay? I mean, it's like days. And it's not just the Lasco tool, the Soho tool, but it's also the Stereo A tool. Two different satellites. So it's an issue with the site. They're not uploading data for whatever reason. Well, I got ideas why, but but we had a CME over here. Okay, you're gonna notice it really, really quick, like, because it is very bright. Okay, see it erupting right there, and boom. It's not a huge one, guys. Okay, but what struck me about this particular one is, number one, the brightness of it. Okay, this is the red filter here. We don't usually see it that bright. Okay, and it was a small one. Okay, but it held like a shape of a ball for a very long time there, and it looked like it was moving pretty quick. Okay, within the course of, let's see here, that's 7:04. It goes from there. That's at 4 a.m. It took it, I don't know, what we say, 12, 16 hours to go completely off the screen. It's traveling pretty fast, guys. Okay. But yeah, so I did want to show you that. Now, this right here is kind of some compelling stuff that I really wanted to show you. I kind of mentioned this the other day, but this thing is doing something. It's still doing it, okay? And this is, I was mentioning the other day on the magnetopause model how, I'd seen those signatures, guys, that reminded me back in 2012 where the magnetopause actually reversed to the other side. And I'm kind of seeing stuff like that now, okay? I'm not saying that it has done that. I'm just saying that some of the stuff I'm seeing, and this is a radiation belt, okay? It's what you're looking at here. Again, the sun is off to the right, hence why we have a curve on that side. Now watch. Okay, there was some pretty decent, we see that energy all the time come in, and it spirals in. It's very normal. Now we start seeing these little contortions, right? It started with that. Okay. Then we get that bigger one. Now watch what this thing does. Okay. Why did the curve go to the other side? Okay, and then even on top of that, you can see how even the outside line stretched out like straight almost. You see that? Now, if I'm looking at this and somebody was to see that for the first time, their first initial knee-jerk reaction would be, oh my gosh, it flipped to the other side. And it might have, guys, for a second. I don't know. But that definitely does look to be some... that's normal right there. That is not. Okay? And so you're seeing all this, right? I mean, more energy, and it kept bouncing around like that for quite a few hours. Okay? So, anyway, guys, I am going to end the video right there. I'm going to show you guys this one more time. Look in the back there. Looks like the earth ate some beans or something. But you see that, how it's just blowing out the back? I mean, it looked very much like a freaking solar flare or some sort of a coronal mass ejection or something. That, I mean, again, guys, I'm not saying that that's what happened. Okay, please don't think that. All I'm saying is that we released energy like that, and it came from inside. It didn't come from an outside source. That definitely came from our magnetics shooting out. Okay, that's what caused that. So, but yeah. So, guys, just keep your heads up. No fear, guys, at all. Don't fear, guys. I mean, be aware. That'll cut down on some of that fear, I promise. The more you know, the less of the shock factor you get. Okay? And that shock factor, and I've talked about this before also, that's when you're the most scared. If you think back in your life when you were the most scared, it's when you got shocked with something. Something scared you that you didn't expect to happen. That's probably the most scared you've ever been in your life, ever, if you just were to think about it for a minute. So if we can kind of buffer that and make that kind of go away, because we get a lot of people saying it's fear this and fear that and fear this and fear that. And that's not the basis of what I do. I think you guys know that. You know, so when we're saying things like that, we're saying, you know, this is real stuff that we're talking about, but we're doing it in a way that it's to bring awareness to it, not to bring fear there. Okay? It's to actually, on the back end of it, you're going to be less scared, is what I'm trying to say. So, anyway, I'm going to end it there, guys. God bless. Yeshua saves, and you can drink this Kool-Aid.